Welcome to Activity 3.3, Complex Systems that Begin Moving. So our learning target for today is we're going to explore how devices begin to move in the direction they do. And you're going to get more practice with drawing free body diagrams for Activity 3.3. And again, this is very, very important that when I ask you to pause the video, you actually pause the video, you try to draw the free body diagrams. Then look at the answer key and adjust your diagram so that it's correct. And I know that some of you have the idea that, oh, why don't I just go to the answer key and draw it in correctly the first time? However, that's not the best way to learn. We learn from our mistakes. So if you just copy stuff down all the time, you're not learning. And that's what I worry about, that we get to the test and because you don't have something to copy, you don't know how to do it. You're not practicing. Just like in basketball. As a coach, I don't have my kids play a game the very first practice. We practice. In fact, this year we have like 11 practices before our first game. So we practice so we can do it right in the game. And that's what this is today. We're practicing drawing free body diagrams so that way you'll have it ready for the test, which is our game day. So here it says you're not gonna have time to construct a free body diagram for all 4 apparatuses. Disregard that. You'll have time in class to do this. And so if you read through the directions, it's not always clear, but it says use these models to help you construct free body diagrams. So in lesson 2, you constructed models that represent these apparatuses. So you can go back and look what you drew in lesson 2 to help you out. So hopefully you have good notes from lesson 2. So, in the floating magnet, so this is where we had the magnet in the test tube. What you need to do is you need to draw a free body diagram to explain how it's moved. So in your book, it really doesn't explain this too well, but you'll really only need a free body diagram. Back in lesson 2, you already explained in words why it moves, and you already looked at the forces. Now what you're going to do is you're going to practice drawing free body diagrams. So you're going to have the upper magnet, the lower magnet, the earth and gravity and weight. These were all the various things that were involved. So go ahead, pause the video and practice drawing a free body diagram that would help explain why the floating magnets, explain why the upper magnet floats. So go ahead, pause the video. Now that you've had a chance to try it, let's look at the answer key. So how did you do? You have the upper magnet, the lower magnet is pushing up, and it's a force that acts at a distance because it's a magnetic force, and then you had gravity pulling the upper magnet down. That's why it stays put. And these are equal, that's why it stays put. If this was much larger, it would be moving in one direction. Or if weight was much larger, it would be coming down and would be touching the other magnet. Even though the other magnet was pushing up on it, the force of gravity would be pulling it down too much. But because they're equal, and we know that they were floating, they're going to stay motionless in that spot. So how did you do with this one? So let's try another one. In a magnetic can, explain why the last ball begins moving. Draw a free body diagram to explain this. So go ahead, pause the video, and see if you can draw a free body diagram. So how did you do? Did you complete it? I'm not going to show you the answer key right away because I want to make sure you understand the directions. Did you practice drawing this first? All right, so here is the answer key. How did you do? So you've got the magnet pulling on ball E. You've got ball D pushing ball E, and it's a larger arrow because ball E flies off in that direction. And you have the rail pushing up, which was our table, and we had our meter sticks on both sides. And you had the weight pulling down, and these were the same because the ball was not moving up and down. It was moving in one direction, and that's why this arrow is so much larger. So how did you do with your practice? So let's try another one, air-powered car. Think of the car and the fan as a single object to figure out why it starts moving horizontally and draw a free body diagram. So go ahead, make sure you pause, make sure you practice. Drawing this should only take you a minute or two, so it's not like it's going to take you 20 minutes to practice this. So go ahead, pause the video, practice drawing your free body diagram. All right, so now you've had a chance to draw it. How did you do? So here's the car and the fan, and they put it all as one because they were taped together, so they act as one. If you, it's an air-powered car, so you almost have to have them together. You can't separate them because you don't want to draw a free body diagram. You'd have to either draw a free body diagram for the fan, the car, or the car and the fan together. Again, these two are equal because the table's pushing up and the weight's pulling it down, and the car's not moving up and down. It's moving horizontally. And that's where you have the air pushing on the car. Now, one of the things I might have added to this, I might have had a dashed line showing some friction because you had the wheels on the table having some friction, but that would be a smaller line than this one because the car definitely moved, at least until someone dropped it off the table. It still moved, just not quite as fast. So let's practice one more. The flying balloon. Treat the balloon and the straw as a single component, so draw it all in one rectangle, and explain why it starts moving. So go ahead, pause the video and draw a free body diagram to help explain this. Again, it's very important that you practice drawing these free body diagrams prior to just looking at the answer key. So how did you do? Did you actually try, or are you just waiting for the key and to copy that down? Again, that's not how learning takes place. Learning takes place as we learn from our mistakes. So here's the answer key. So change your model so that it's now correct. But how did you do? Are you getting this mostly correct? If you're getting these mostly correct, you're ready for the test that's coming up. If you're struggling with these, or if you're just copying these down, I'm afraid that you're going to struggle on the test if you have to draw on a free body diagram, which you may not have to do in this test, but eventually you will have to do. So now that you have these done, go ahead and answer the rest of the questions. And as always, when you get done with the questions, ask. And if you were doing this outside of class, obviously you're not in class. So if you want to sit down, we can go through this together. You can check it over with a partner who was in class. If you're in class, we're going to go through these together as a class. But I do have one scientific principle I want you to add. Forces that are applied to an object in opposite direction counteract each other. Forces that are applied to an object in the same direction reinforce one another. So when we looked at some of these models, and I'm trying to find a good one here. So these forces counteracted each other. So they didn't lead to motion. So sometimes when they counteract things, there is no motion. Forces that are applied to an object in the opposite directions counteract each other. Forces that are applied to an object in the same direction reinforce one another. So this would be, a good example of this if your car ran out of gas, or if your parents' car ran out of gas. If you got out and you tried pushing the car and you couldn't move it, but then someone else got out of the car and started pushing with you, and all of a sudden the car started moving, you're applying a force, they're applying a force. They applied a force that reinforces the force that you're applying to an object. So make sure you add these scientific principles, and as always, make sure you ask questions if you have any.